So again, Egg Base, let me bring your attention back to the test. Okay, 25 miles, laser 2 meters off the ground.
It's the Pythagorean theorem.
2
you don't
meters
square
off
it and then keep it squared.
Pythagorean theorem.
You don't square. If you're in the Pythagorean theorem and you're doing a squared plus b squared equals c squared, you don't do a squared plus b squared and then assume that c squared is c. You do the square root of c squared. So what you're saying is that because miles need to be squared in order for the Pythagorean theorem to function, you don't take the square root afterwards, and you're assuming that 200 whatever must be feet.
Automatically that has an issue because the equation for a circle like the circumference of the Earth is x squared plus y squared equals the radius squared. So whatever change you get per unit would be applied to that x squared. So if it's 8 inches per unit, you're going to get 8 inches per x squared or 8 inches per mile squared. In the chat, we have the derivation of the 8 inches per mile squared. It's actually 8.0327 inches according to the math here. But you can look at the derivation there if you want to see how they get 8 inches per mile squared.
Yeah. So look, Eggbase, I'm not gonna argue with you about this. Man, I've been over this problem many a times, and you're not gonna tell me how much curvature there is or shouldn't be. I know, okay, factually, according to your model, how much drop there should be in this distance. So
16.7.
It's pretty obvious. No, look, yeah, we've been over this multiple times, okay, and it's not 16 feet. Okay, in 25 miles, 16 feet. In 25 miles, dude, there's about a 120-foot wall in the way. Now, my question to you is, how does the laser hit the target?
Sorry about that, but you really don't know your model, bro.
Because the laser curves. What do you mean?
How does so can you how does the laser curve over the ball perfectly over 25 miles? The laser's curving perfectly to the shape of your Earth to hit the target. Is this hold up? Is this what you propose? Wow! So you literally Egg-based. You literally just had the nerve to tell me that a laser is bending perfectly at the curvature. Okay.
Someone's got some background.
Okay, yeah, you have the nerve to tell me that the laser's perfectly bending at the rate you need it to hit the target? This is what you...
Oh, it doesn't bend at the rate that I need it to.
It does, though. That's what you just said. I asked you, how did the laser hit the target? And you said the laser bent. And I can conclude from that you're telling me that the laser bent perfectly around the shape that you need it to hit the target? This is what you propose?
That's not. You're
listen to this kid.
You're saying that a causative relationship is correlative.
No.
And what we're saying is we have a direct line of sight. It's basically this. We see things in the distance that are there. According to your model, after a distance, they shouldn't be there. So what we do is we confirm this. We use a laser, super accurate laser aiming device, to paint the target at a vast distance. This would require a direct line of sight. So the observation needs a direct line of sight and the laser needs a direct line of sight to hit the target. Now this is quite easy to understand. I see something, I target it because it's there, directly in front of me. The contention is that the object that I'm viewing or the target should not be able to be viewed or be able to be hit by the laser. Both object and target in the observation and the demonstration of the laser hitting the target have descended beneath the curvature of the Earth. A direct line of sight is not in this case possible because the curvature of the Earth is in the fucking way. That's easy to understand.
The longest line of sight on the ground is 54 kilometers.
Someone interrupted what?
The longest line of sight on the ground is 54 kilometers.
What altitude is this?
Oh no, the longest line of sight at the peak of Mount Everest is 336 kilometers.
Depending on air clarity and if you're using an infrared camera. It appears to be the longest observation made by an infrared camera is over 1,000 miles from 36,000 feet. Witnessing things in the distance that should descend miles and miles beneath the curvature. So we can look at the horizon if you want. We're talking about observations and laser tests. You said that the laser was being curved around the curvature of the Earth. Is that correct?
Bent.
Which wouldn't be very much over a span of 25 miles. It would be about
25 miles. Between point A and point B, that's over 270 odd feet of drop.
That's not true.
It's not true.
Is. Yeah, no matter how much you say it's not true, it is. I'm sorry, dude.
I'm posting my math right after yours. Here
this
it is.
Is your model.
Yeah,
no, this
your
is
math.
my model.
No, your model is 24,901 miles.
This is
your WGS84 model, the most accurate model there is.
A squared equals 39,632 plus 12 equals 100. It's 15,705,370. Thus, A equals 3,963 miles. Thus, your position is 3,963 minus 363
you spam that
equals
on the chat. We can see it. There is no need for you to chant it along. Okay, we can see it. We can read it. What you need to do now is to direct your attention on the meme, 90 meters meme that was posted. So this is such a dead argument that it has been turned into a meme long ago. So
the egg base, the problem is that's in 1 mile. The last sentence is the key. Hence, the Earth's surface curves approximately 8 inches in 1 mile, but over long distances, it's 8 inches per mile squared. Let me walk you through the derivation.
It doesn't increase.
But
no one pretends that it increases.
But it would have to over that it's constant. It would be a slope. It would be a straight line slope.
No, the curve is constant,
we're not on a slope. We're not on a slope. You have to square the mile to get the exponential function because you're on a curved surface.
Dude, yeah,
right?
I would just like to point out, Eggshell, dude, you don't know what you're talking about. You have